Part E, Curriculum Integration. The following is a recording of a summary of the conversation between a math teacher and myself, which focuses on the integration of mathematics and chemistry in the teaching of Hess's law to a Unit 1 chemistry class. Good morning, Ms. Ramnarayan. Thank you for agreeing to assist me with this integrated lesson.
Good morning, miss. That's no problem. So what exactly were you thinking about doing today?
Okay, so there is this topic called Hess's law. It involves calculating energy changes for a specific reaction, and the students keep getting the answers wrong. I was hoping that there was an easier mathematical way that you could show me to help them.
Okay, well, I think I have an idea of Hess's law from school, but that was so long ago. But anyhow, you have a example we could start with?
Yeah, sure. This is an easy one.
Okay. Oh my God. This is a real long question, plenty words in it.
Yeah, and you know how our children get turned off so easily when they see so much words.
I know exactly what you're saying. Okay, let me just read it through and see if I can help you out with this. Well, it looks as though you have to use the energy values that was given there to calculate the missing one, right?
Yeah, but it really isn't so easy, yeah? Because it's actually three reactions going on here. And then
Okay.
each reaction has a certain amount of energy associated with it.
Okay, wait. You say something that very important here. This reactions. It means you have arrows separating the reactants and the products, right?
Arrow, yeah.
Well, if there's arrows involved, that makes me think of vectors. You remember vectors from Form 5?
Yeah, but wait. Just confirming, vectors, that's a topic on their syllabus, right?
Yeah, the C-Sec syllabus. Let me just pull up the objective, right?
Mm-hmm.
Okay, so it says students should demonstrate the ability to use vector notation and concepts to model and solve real-world problems.
Okay, well, actually, calculating overall energy change for a reaction is a problem in the real world. Like if they're going on to do something in chem. So,
Right, so they should be able to do it with some guidance, of course. But vectors is also a topic in Unit 1 syllabus, in the pure maths.
okay, well, good. Then, all right, let's try to look at it again then, no?
Right, good. So, okay, you have three energy changes. You might be able to use the triangle law. You remember the triangle law?
Gil, that was so long ago for me. Just give me a little review.
Okay, I know, don't worry. It's just like that with me and Heslo. Okay, so basically, right? If the arrows point across, down, and then back up, right, then to calculate the magnitude of the vector going across, you just add the magnitude of the one that going down and the one that going back up.
Okay. Well, that's sounding easier, but will it apply if the magnitude is actually an energy change? Like an energy
Well,
value?
okay. Is there any way you can arrange the equation to form a triangle?
Um,
such that the arrows are pointing across, down, and then up again.
the equations themselves.
Yeah,
Okay, what about like maybe like this?
yeah, that's perfect.
Mm-hmm.
So once the arrows in the right direction, you could use the triangle, or just like this, the arrows are following each other.
Okay, so what I have to do then is just put in the energy changes on the arrows then.
Exactly.
Okay.
So let me see. According to the values you substitute, right? Um, the answers should, the answer should be negative 189 kilojoules per mole.
Oh my God, yes. Hey, that's the right answer.
Okay, then triangle law to the rescue.
I guess so. Hey, that's really exciting. So, but will this always be true? Like this method?
Yes, it will. As long as the arrows are pointing in the right direction and they substitute the values correctly, they should get the right answers. We could try a few more to make sure if you want.
Okay. Well, the good thing is the majority of this class really loves maths. It's like their favorite subject.
Yes, I know these students. I taught most of them in Form 4 and Form 5. And this is a topic they're really, really good at. So, this application of triangle law you are proposed today will be new to them though. So, you'll probably have to do a couple of examples for them to get it at first.
Well, I am really going to try to reteach the HESS law, but I'm using this approach instead.
Okay, good. I'm really glad that you're going to use this. Because you know how them children them. They always ask and miss how this helping me in real life, how this helping me in real life.
Oh God, yes. And if you can't give them an example right away, well, that's it. They just turned off.
That's so true. But wait, so what method you was using before?
Right. So the method from before was this real long drawn out method. This is what it used to look like. And they had to write these long statements and then try to figure out what the energy changes happening really were.
Oh gosh, no wonder they having trouble. These kids really enjoy seeing information in a more concise way. Right? So they're not so good at English, sorry to say,
Hmm.
but they're real good in maths. So mostly the information that they need to see it in a more, concise way, a more simpler way. And
Yeah.
especially with the visual, with the arrows and thing, that will help them out.
Well, I think they love maths because it has a lot to do with the teacher that they have, eh? But this triangle is definitely like more appealing to look at. Like I'm looking at it and I'm feeling less stressed out about working these questions. I find you have a real talent to be able to see like a math solution in a situation even as abstract as this.
Well, thanks, Miss. It's making me feel real good here. But over the years, I found that what really helps me in teaching maths is to integrate, like, different topics. So, the students and them could see applications, in the other subjects that they're doing, right? And it helps to link the math concepts, sorry, to the other subjects that they really like. And I know chemistry is one of the best, the favorite subject too. So
Oh,
Miss do a real good job with them because they
well,
always talk about chemistry.
well, I don't know, but I started to realize that this integrating subjects that really does have a lot of benefits.
Yeah, that is true. That is true. The integration of different subject areas, I think, really helps the students,
Mhm.
right? And I really hope that the next time you see lower six science, right, they would enjoy this Hess's law now using these vectors.
Well, I really hope they do, because I want it to work not just for chem, but also for maths.
Yes, it will work for maths. Don't worry. I'm sure of it.
Okay. Well, thanks so much for agreeing to do this integration with me, Ms. Ramnarine.
You're most welcome, Ms. Dharmaraj. Let me know how it goes, right?
I will. Thanks so much.
No problem.